Hai semua, dalam video ni kita akan bincangkan the reaction mechanism untuk electrophilic aromatic substitution of the benzenes. Untuk menulis reaction mechanism for electrophilic aromatic substitution akan melibatkan 3 langkah umum, iaitu Step 1, formation of electrophile, Step 2, formation of arenium ion, and Step 3, deprotonation of arenium ion. Bagi tindak balas yang seterusnya yang kita akan bincangkan iaitu Friedecraft alkylation of benzene. How to write the reaction mechanism for this reaction. Bagi tindak balas Friedecraft alkylation of benzene, reagent yang digunakan adalah haloalkanes in the presence of Lewis acid catalyst. Persamaan menunjukkan tindak balas di antara benzene dengan haloalkanes in the presence of Lewis acid AlX3 and produce an alkyl benzene. Bagaimana menulis reaction mechanism untuk tindak balas Friedecraft alkylation of benzene? Mari kita lihat contoh yang pertama. For the first example, let's say we have a benzene react with chloroethane in the presence of AlCl3, the reaction produces ethyl benzene. How to write the reaction mechanism for this reaction? The first step is to show the formation of electrophile. In this step, the lone pair from the chlorine atom of the chloroethane will share its lone pair to the aluminium atom of the Lewis acid, and then breaks the bond between the carbon and the chlorine atom. This reaction will produce a primary carbocation and the AlCl4 1-. From this reaction, it shows that the catalyst has polarized the haloalkane molecule and then the complex form dissociate to form a primary carbocation. The second step is to show the formation of arenium ion. Since the benzene ring is the rich electron species, thus the benzene ring is always a nucleophile. The carbon-carbon double bond of the benzene ring will attack the positive carbon of the primary carbocation and form a bonding to form arenium ion. In arenium ion, the pi electron is delocalized from one carbon to the next carbon positive. Thus, the pi electron will move in a circle in order to stabilize the carbocation. This structure is called a resonance structure. The final step is deprotonation of arenium ion. In this step, the nucleophile of AlCl4 1- that produced from the first step will remove the proton in the arenium ion and restore the pi system in the benzene ring. Thus, it will produce a stable alkyl benzene and the catalyst of AlCl3 as well as HCl. Now, let's discuss for the second example. Let's say we have a reaction between the benzene and the chloropropene in the presence of AlCl3 as a Lewis acid catalyst. This reaction will form an isopropyl benzene and the HCl. But now, how to write the reaction mechanism for this reaction? The first step is to show the formation of electrophile. The lone pair from the chlorine atom of the chloropropene will share its lone pair to the aluminium atom of the Lewis acid and breaks the bond between the carbon and the Cl atom. This forms a primary carbocation and the AlCl4 1-. As we can see, the carbocation can be rearranged to get a more stable carbocation. Thus, we proceed to the next step that involves the rearrangement of the carbocation. The second step is to show the rearrangement. From the first step, we have produced the primary carbocation. The hydrogen atom from the neighboring carbon can be rearranged to the primary carbocation to get a more stable carbocation, which is the secondary carbocation. This reaction is called a 1,2 hydride shift. The rearrangement of the carbocation is possible by occurring the 1,2 hydride shift to form a more stable secondary carbocation. The next step is to show the formation of the arenium ion. Since from the second step, we have produced a more stable carbocation, which is the secondary carbocation. Thus, this secondary carbocation will be the electrophile to react with the benzene. The benzene ring, which is the electron-rich species, will be the nucleophile. The pi electron from the benzene ring will attack the positive carbon of the secondary carbocation to form a bonding. This reaction will form an arenium ion. The arenium ion is less stable due to the positive charge to the carbon atom in the benzene ring. Thus, the pi electron in the benzene ring will delocalize in order to stabilize the positive carbon. This structure is called a resonance structure. The final step is to show the deprotonation of arenium ion. In this step, the nucleophile of AlCl4 that produced from the first step will remove the proton in the arenium ion and restore the pi system in the benzene ring. This reaction will form a stable alkyl benzene as well as the Lewis acid catalyst of AlCl3 and the HCl. Now, let's discuss for the third example. Let's say we have a benzene react with methyl chloride in the presence of Lewis acid of AlCl3 to form a toluene and the HCl. How to write the reaction mechanism for this reaction? The first step is to show the formation of electrophile. In this step, the lone pair from the chlorine atom of the methyl halide sharing its lone pair to the aluminium atom of the Lewis acid. From this reaction, it shows that the catalyst polarized the haloalkene molecule. The complex form consequently acts as an electrophile. The second step is to show the formation of arenium ion. Since in this reaction, the benzene ring is the electron-rich species, which is the nucleophile, the pi electron of the benzene ring will attack the methyl group of the electrophile and breaks the bond between the methyl and the chlorine atom. From this reaction, form the arenium ion. The arenium ion consists of carbon with positive charge. This destabilizes the benzene ring. Since the benzene ring consists of the pi system that is able to delocalize in the ring, thus the pi electron will be delocalized in the ring to stabilize the arenium ion. This structure is called a resonance structure. The third step is to show the deprotonation of arenium ion. In this step, the nucleophile of AlCl4 that produced from the first step will remove the proton from the arenium ion and restore the pi system of the benzene ring. From this reaction, forming a toluene and the Lewis acid AlCl3 and HCl.